Finding linear function equations in context. We've been working in class with linear functions, and the first thing we learned how to do is if we're given the equation, standard form or slope-intercept form, we should be able to graph all the solutions to the equation. Then we went backwards and said if I know at least 2 points on a line, I should be able to find the equation of the line that goes through those 2 points. So we're going to take that one step further, and what we're going to do now is we're going to identify coordinates of points in a specific context. So the only difference between what we're doing now and what we did before is you'll understand what you're talking about, because there's actually real-world references that we can make here. Take, for example, crickets. It does turn out, and this is a fact, I don't know how accurate these data are, but it is a fact that the warmer it gets, the more frequently crickets will chirp. And if it's colder, then the crickets will chirp a little slower. So their biology depends on the temperature. What I learned here, when I read the first paragraph, observe the chirping rates is related to temperature. Right off the bat, I know the chirp rate is a function of the temperature. So temperature is going to be the horizontal axis value, and then chirp rate, or chirps per minute, is going to be the vertical. So chirps per minute depends on the temperature. The next thing I see in the paragraph is appears to be very nearly linear. So what we're going to do is assume that the authors of this problem intended us to use a linear model. And that's what part A says right there. Find the linear equation. And here's my data. A cricket produces 120 chirps per minute at 70 degrees, 168 chirps per minute at 80 degrees. This last sentence should be converted into coordinates of a point. So when I read the paragraph, I read 7, 120 chirps per minute. Depends on a 70-degree temperature, 168 for an 80-degree temperature. I plot the points. So following this paradigm for every application problem, the first thing I do is I read the paragraph and try to find 2 points. I did that. I plot the 2 points. Done. Draw a line through those 2 points and estimate the slope and the y-intercept. So the slope and the y-intercept, the y-intercept is interesting because it appears as though the line is going to cross way down here in negative land. And if I extended the line, I might find that it probably intersects somewhere when y is like negative 200 something. Just from looking at this is negative 50, 100, 150, down here to negative 200. So it's not going to be relevant because that means at the y-intercept we're talking about 0 degrees Fahrenheit. There aren't that many crickets out right now in 0 degree Fahrenheit weather. So this is one of those functions that will have a limited domain only in the first quadrant. We're not going to mention temperatures that are below freezing or even below 50 degrees for that matter. So the y-intercept, though, nonetheless, has to be defined, and it will be a negative number. And the rate of change, the constant rate of change, if you will, appears to be somewhere, well, we're going from 120 to 168. So that's just under 50, and this is a 10-degree change. So I'm going to say that the rate of change, or the slope, is going to be around 5 chirps per minute per degree. Probably a little less than that because of this 168 piece. So let's see how good, well, let's see, I'm trying to find my calculations here. So right down here, I actually did calculate my rate of change using the subtraction for change. So 168 minus 120 gives me a 48-degree change in temperature and a 10-degree change in, chirps per minute, 10-degree change in temperature for an average of 4.8 chirps per minute per degree. That label is important because it tells us then that every 1 degree warmer we get, we're going to get an extra 4.8 chirps per minute from the original. Now my task is to actually get to the equation of the line. And so, just like we did in class, once we've identified the slope, we could put that there. And then all we have to do is take any one of these 2 points, I'll take the closest one, and walk it home. Walk it to the origin. So the y's have to go down 120, so I make this minus 120. And the x's have to go back 70 to get back to the origin. Here's my back 70 right here. The rest is algebra. You distribute the 4.8 and add the 120. And you end up with C of x equals 4.8 minus x minus 216. So C of x represents chirps per minute. X represents temperature in degrees Fahrenheit. The negative y-intercept basically means crickets are not chirping at 32 degrees below freezing. The domain is probably going to go from 50 degrees up to 100 degrees. That's just my best guess. So here's the deal. Now that I actually have a function equation and a function graph, I can answer any question about these crickets within the given domain. For example, what is the temperature if I listen to my crickets and I find that they're chirping at 150 chirps per minute? The first thing I could do is find 150 chirps per minute on the y-axis, follow it over to the line and down, and I can see it's probably going to be around 76 degrees out. I wish it was that temperature now. And of course, this point right here gives me the actual correct answer, but I could see it from estimating on the graph. So I look at the graph first to predict my answer, and then I do the algebra. The algebra says we have 150 chirps per minute. That's the y value in my linear equation. So then I just solve the equation for x and find 76.25 degrees Fahrenheit if the crickets are chirping at 150 chirps per minute. So any question I wanted, for example, I could say, well, if 60 degrees, if it's 60 degrees, how fast are the crickets chirping? I could follow the graph up, follow the graph over, probably around 76 or 78 degrees or something like that. And then I could use the equation to find C of 60 and get a better approximation or, exact value. And yeah, in a nutshell, that's what we're going to do. In these problems here, each of these problems is either going to give you a slope and a point, or they're going to give you two coordinates of 2 points. And then you basically do the exact same thing that I did with chirps and the same thing we did with every problem in class. So enjoy. Have a good day.